Hi everyone, for today's lesson we are going to learn about the quadratic formula and its discriminant. Our learning objectives for today is for you to be able to say, I can solve quadratic equations using the quadratic formula. So we are solving quadratic equations. So far in solving quadratic equations, we have learned how to solve using factoring, square roots, completing the square, and now finally quadratic formula. I can use the discriminant of the quadratic formula to determine the number of solutions as well as type of solutions of a quadratic equation. So it's number and type. So the number and type of solutions. What's really cool about the quadratic formula is that the quadratic formula can be used to solve any quadratic equation. And that's why a lot of people really like the quadratic formula, because if you have it memorized, it's very, very just plugging numbers in and getting numbers out. Now, just because it can be used to solve any quadratic equation doesn't mean it's the most appropriate method. It's only the most appropriate method when factoring is inappropriate, or when you have it in the form of ax squared plus bx plus c and it cannot be factored. So that is something I want you guys to know. So it says the equation must be equal to 0, just like we've had with many of the other types. The equation must equal 0 before you use the quadratic formula. The solutions to the quadratic equation written in the form of ax squared plus bx equals c can be found using the quadratic formula. And this formula is particularly useful when a quadratic equation cannot be solved by factoring. So I've mentioned it a couple of times. Cannot be solved by factoring. So it's in this structure, it's equal to 0. It's not in the nice form that would be appropriate for using completing the square. It's complicated. It's not a nice problem, and you can't factor it. So I want you guys just to be aware of that. It must equal 0 as well. So in your quadratic equation, it is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All over 2a. And that is how you solve quadratic equations. Remember that solutions are x-intercepts. So I'm going to write it over here. They're x-intercepts. They are solutions of the equation. They are zeros of the function. They are the roots of the equation. All of those words mean the exact same thing, and that's why it's x equals. And this formula, once again, is only appropriate when you cannot factor. So here's a really quick trick just to let you guys know. If b squared minus 4ac is a perfect square, then the quadratic is factorable. So I just want you to know that if b squared minus 4ac is a perfect square number, then the quadratic is factorable. So that is this part right here, b squared minus 4ac. So that is something I want you guys to be aware of. We use b squared minus 4ac a couple of times. It's called the discriminant. And I want you guys to pay attention to what the value of the discriminant is as we are going through our problems. So it says solve using the quadratic formula for each of these equations. We need to make sure that we write our answers in simplified radical form. And please note the number and the type of solutions that we will end up having. So remember, all quadratic equations have to equal 0. They have to. So that means that I need to bring 16 to the other side by adding 16 to both sides. When you do that, you end up with 2x squared plus 12x plus 16 is equal to 0. Now I'm going to use the quadratic formula. So to use the quadratic formula, I need to identify what x equals, or what a equals, what b equals, and what c equals. So in this problem, my a value is equal to 2, my b value is equal to 12, my c value is equal to 16. And I'm going to write x equals the opposite of b. So the opposite of 12, or negative 12, or sorry, excuse me, the opposite of 12 is negative 12, plus or minus the square root of b squared. So that is 12 squared, minus 4 times a, 4 times 2, times c, which is 16. This is all over 2a. That's 2 times 2. Your next step is to just put in this stuff underneath the square root. Just put that stuff into your calculator, that expression into your calculator with no root, no radical. So we're just going to put in b squared, so that is 12 squared, minus 4 times a, which is 2, times c, which is 16. Just put that value into your calculator. What you end up getting is 16. So I have x equals negative 12 plus or minus the square root of 16 all over 2 times 2, which is 4. So now this is x equals negative 12 plus or minus the square root of 16 is 4. This is all over 4. So now because there's no radicals, what I'm going to do is separate this into 2 separate pieces. I have x is equal to negative 12 plus 4 divided by 4. And I have x equals negative 12 minus 4 divided by 4. So this is going to become negative 12 plus 4 is negative 8. Negative 8 over 4 is negative 2. Down here I have negative 12 minus 4, which is negative 16. Negative 16 over 4 is equal to negative 4. We ended up with 2 solutions, negative 2 and negative 4. They are both real numbers, so we ended up with 2 real solutions. And those 2 real solutions were negative 2 and negative 4. If we were looking at x-intercepts, they would be located at negative 2, 0 and negative 4, 0. 2 locations on our graph in which this quadratic would cross the x-axis. Also notice something. We took the square root of a perfect square number, 16, and we ended up with rational answers. What this means is that this problem was factorable. And technically, the quadratic formula was not the most appropriate method. Could we use it to solve? Absolutely. Is it the most appropriate? No. Factoring would have been a lot faster and way less steps. Let's go ahead and look at number 2. For example number 2, we have 4x squared minus 13x equals 7x minus 25. In this problem, we want it to equal 0, and we also want to make sure that our leading coefficient remains positive. So what I'm going to do is I'm going to subtract 7x on both sides, and I'm also going to add 25 to both sides so that I end up with this equation equaling 0. So I have 4x squared minus 20x plus 25 is equal to 0. My a value is 4, my b value is negative 20, and my c value is 25. Using the quadratic formula, I have x equals the opposite of b, so the opposite of negative 20 is positive 20, plus or minus the square root of b squared, so that is negative 20 squared, minus 4 times a, which is 4, times c, which is 25. This is all over 2 times 4. All right, just like before, we're going to put negative 20 squared minus 4 times 25 into our calculator. This is known as the discriminant. And it's a lot easier of a problem if you just put this piece into your calculator to figure out what that value is. So we have parentheses, negative 20 squared. Be careful here. A lot of kids won't put the parentheses and they'll end up with a negative 400. So please, please, please be very careful. Write your answer exactly as you see it right here. So that's how you type it into your calculator. So we have negative 20 squared minus 4 times 4 times 25. So exactly parentheses and all in my calculator, and I end up with the number 0. So I have x equals 20 plus or minus the square root of 0 over 8. Well, the square root of 0 is 0, and I end up with x equals 20 over 8. They're both divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. So the answer is 5/2. This is one real solution. X equals 5/2 is our 0. It's our solution. It's our root. And 5/2, 0, would be our x-intercept. So we ended up with one real solution. Look at what that number ended up being. It ended up being 0. Anytime that you see your radical being 0, that means that what you started off with was a perfect square trinomial. If you have a perfect square trinomial, quadratic formula is not the most appropriate method. Could it solve? The answer, of course. Same thing with this factorable question. Can you get a solution? Absolutely. Quadratic formula will solve any type of problem. Is it the fastest? No, not by far. This is a lot more work than just recognizing from the very beginning that you have a perfect square trinomial. In this problem, factoring would have been the most appropriate method. I'm repeating myself of saying what's most appropriate, and that is because one of the skills and one of the things that I need you to know from this class is when to use which method and approach for solving quadratic equations. So far, I haven't shown you one that makes the most sense for using the quadratic formula. But hopefully number 3 will help you guys out. Let's look at number 3. In number 3, I need this equation to have two things. Number 1, we need the equation to equal 0. And number 2, we want the leading coefficient to be positive. We want the leading coefficient to be positive. So that basically means we need a positive a value, because our leading coefficient in this problem is -1. So this says positive a value over here. So that means instead of me simply bringing 5 to the other side, instead I am going to add x squared to the other side and subtract 2x on the other side. By doing that, we now have 0 is equal to x squared minus 2x plus 5. My a value in this problem is 1, my b value is -2, and my c value is 5. And I'm going to write x equals the opposite of b. The opposite of -2 is +2, plus or minus the square root of -2 squared, minus 4 times my a value is 1 and my c value is 5. This is all over 2 times 1, 2a. Just like before, we're going to put what you see underneath the radical inside of your in your calculator. We're going to enter it. So I'm going to put parentheses, -2 squared minus 4 times 1 times 5. And I end up with -16. So I'm going to write x equals 2 plus or minus the square root of -16 divided by 2. Well, I know that the square root of negative 16, because it's imaginary, I am going to work with imaginary numbers. That is okay, especially in this unit. So that means that I have x equals 2 plus or minus. This is the square root of 16 is 4. Because it's negative, we have 4i divided by 2. And because this turned into a complex number, that means that I need to separate into two pieces and simplify. So that means that I have x equals 2 over 2 plus or minus 4i over 2. And I'm going to simplify it one step further by making this 1 plus or minus 2i. In this problem, plus or minus indicates that we have two solutions. And these solutions, because there is an I in it, means that we ended up with two imaginary solutions. That means that this parabola does not cross the x-axis at all. And so it's what we call a floating parabola that doesn't cross or touch the x-axis. There are no x-intercepts. But their solutions, they just ended up being imaginary. And as you get further along in your education of mathematics, you learn that there exists a new axis called the imaginary axis. But for right now, we're just going to leave it as no real x-intercepts, but there does exist solutions. They are just two imaginary solutions. So yes, in this problem, it was not factorable. Square root of negative 16, that is not real. This is not a perfect, negative 16 is not a perfect square number. So therefore, this was not factorable. And yes, the quadratic formula was the most appropriate method for us identifying our solutions. So there are three different types of solutions. We have ones where you take the square root of a positive number. That means that you'll end up with two real solutions. One where we ended up taking the square root of 0 and we ended up having only one real solution. Or there's taking the square root of a negative number. And by doing that, you end up with two imaginary solutions. So those are the different types of solutions that you could end up getting by solving using the quadratic formula. I have two problems that I would like you guys to complete on your own. You're welcome to do it when we are in class together. You're welcome to do it right now by pausing the video. But we will discuss them the next time that I see you. Let's go ahead and move on. For our pair, for which examples was using the quadratic formula not the most appropriate method? And what other method would be more appropriate for those problems? Please explain. I know I've already explained it a little bit before, but I want you to recap. I've talked about this a few times, and I want to make sure that you truly understand when it's appropriate to use which method. The other thing that I've talked about a lot is the discriminant. The discriminant, using the discriminant of 8x squared plus bx plus c equals 0. In the quadratic formula, that expression of b squared minus 4ac, the piece of the problem that we put into our calculator, this is called the discriminant. And based on the discriminant, we can identify the number of and the type of solutions that we will end up with. In the quadratic formula, we have opposite of b plus or minus the square root of b squared minus 4ac. The discriminant is what you're taking the square root of. So I want you to see that there's a relationship here. And I'm also going to rewrite this as x equals, but we're interested in just the discriminant. And like I said before, if that b squared minus 4ac ends up being a perfect square number, then the quadratic is factorable. So if you're ever saying to yourself, well, I don't know, I'm not really great at factoring, how will I know if it's factorable? Just try out b squared minus 4ac. Did you end up with a perfect square number of 1, 4, 9, 16, 25, 36, 49, etc.? And if you do, that tells you, go back and keep factoring. because technically factoring is a lot faster than what we're working with here with the quadratic formula. Now, to recap on the discriminant, if the discriminant value is a positive number, regardless of if it's a perfect square, if it's any positive number, then that means that you will end up with two real solutions. That means that the quadratic function crosses the x-axis at two locations. Now, please note that whenever we're looking at these, we're looking at just the b squared minus 4ac with no square root around it. So that's where a lot of kids make the biggest mistakes. We're just talking about the number, the value that is underneath the radical. So I want to make sure that we are all on the same page with that. If the value of the discriminant is the number 0, you end up with a 0. That means that you will end up with one real solution. Just like we saw before, we only ended up with one answer. We took the square root of 0, it ends up being 0. There's only one x-intercept. And finally, if you end up with your value of the discriminant being a negative number, that means that you're going to be taking the square root of a negative number. And if you take the square root of a negative number, you're going to end up with two solutions again, but those will be two imaginary solutions. So knowing when you have two solutions is important, and also recognizing when it's either real or imaginary. That's going to be important as well. It's imaginary if you're taking the square root of a negative number. Notice that in this parabola, it does not cross the x-axis. So that means that there are no x-intercepts. So right here we have two x-intercepts. We have one x-intercept. And right here we have no x-intercepts. I just call it just like this floating parabola that doesn't cross or bounce anything. It just floats. It's a floating parabola. All right, let's go ahead and look at example number 4. In example number 4, we have 2x squared plus 4x minus 4. So in this problem, what we want to do is we want to simply identify b squared minus 4ac. If you notice that they all have something in common, like that is not what we're focused on right here. We simply want to, as written, identify what the discriminant is. So my a value in this case is 2, my b value is 4, my c value is negative 4. And I just want to do b squared minus 4ac. So that is 4 squared minus 4 times 2 times negative 4. And we simply put that into our calculator exactly as we see it. So I'm going to put into my calculator 4 squared minus 4 times 2 times negative 4. And when I do that, I end up with the number 48. So because 48 is a positive number, that means that I will end up with two real solutions. I'm going to go ahead and do this solo one with you because you have to remember that all quadratic equations have to equal 0 before we start analyzing them with the quadratic formula or working with the discriminant. I want my a value to be positive, so I am simply going to bring 24 to the other side, and I'm going to add 4x to the other side. By doing that, I end up with 3x squared plus 12x plus 12 is equal to 0. My a value is 3, my b value is 12, my c value is 12, and now I'm going to use the discriminant, b squared minus 4ac, so that's 12 squared minus 4 times 3 times 12. I'm going to put that into my calculator exactly as I see it. So that is going to be 12 squared minus 4 times 3 times 12. And I end up with the number 0. And we all know what happens with 0. That means that we're going to have only one real solution. I think you can probably figure out what's going to happen in the next solo question, but I want you guys to go ahead and complete that one on our own, and we have one more idea to talk about, and then we are done for our lesson. And that is going back to those vertical motion problems. Before I talk to you guys about vertical motion, we were talking about an object that was being dropped. We had some really fun problems like a math textbook being dropped off the side of a building, and or dropping water balloons onto the ground. And when we did that, we had h equals negative 16t squared plus h sub 0. And that's because v sub 0 was our initial velocity, and it's always 0. That initial velocity is always 0 whenever we're dealing with dropped objects. But now going back to that v sub 0, once again, that represents your initial velocity. That value of the initial velocity, your starting velocity, that value is going to be used whenever you launch an object or throw an object. T still represents time, and final height, or your height with respect to time, is going to be your h, or sometimes called your h of t, depending on the problem. But h sub 0 represents your initial height. What are you starting off at? Are you elevated above the ground? Are you starting on the ground? What is your initial height? Are you dropping an object off the side of a building? So that represents how high you are before at the very beginning of the story problem. So it says a juggler tosses a ball into the air. The ball leaves the juggler's, so this is not the juggler's hand 4 feet above the ground, and has an initial velocity of 40 feet per second. So I have some things in there that I will need to adjust. But anyways, a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 40 feet per second. Write a model for this equation. Okay. So the juggler tosses the ball into the air. The ball leaves the juggler's hand 4 feet above the ground. So this 4 feet above the ground represents where it starts before it is tossed and then lands, because we're juggling, so that we have to think that it's being tossed 4 feet above the ground before it accidentally hits the ground. So in this problem, h sub 0 is going to be equal to 4. And we are told very explicitly that our initial velocity of v sub 0 is going to be equal to 40. So therefore, I'm going to write my model as h equals negative 16t squared plus 40t plus 4. Letter B says, the juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? Round your answer to the nearest hundredth. So the juggler catches the ball when it falls back to a height of 3 feet. So we want a height of 3 feet, and we want to figure out how long it took for that ball to actually reach 3 feet. So that means that we're letting just regular h, not our initial height, but regular h equal to 3. So I'm going to write 3 equals negative 16t squared plus 40t plus 4. And now I need to solve. For t. I need to find out how long t was that ball in the air. What was our time? And I've mentioned this. This is all in feet. So this is our final height in feet and our time with respect to seconds. So this is all about feet and seconds. So I am going to subtract 3 on both sides, and when I do that, that is 0 equals negative 16t squared plus 40t plus 1. And I'm going to use the quadratic formula, but before I do that, let me verify that this is indeed not factorable. So I'm just going to identify the discriminant, and that discriminant is b squared minus 4ac. So I'm just going to put in 40 squared minus 4 times A, which is negative 16, times C, which is 1. And I end up with 1664, so 1664. And I'm going to take the square root of that because that's not a number I work with very often. So I'm just going to verify that, nope, definitely not a perfect square. So that tells me that this is not factorable, and I definitely need to work with the quadratic formula. Now, normally I would recommend that we rearrange our numbers to make our A value not negative. If you decide to keep it negative for these types of problems, that's okay. But you'll see why it becomes kind of annoying whenever you don't have a positive A value. So I'm going to keep my A value negative just to show you how annoying it is. Our B value is going to be 40 and our C value is going to be 1. And I'm going to write X equals, or not X, this is T, excuse me. T equals the opposite of B, so that's negative 40, plus or minus the square root of B squared, which is negative 40, positive 40 squared minus 4 times negative 16 times 1. And this is all over 2 times negative 16. So I have T equals negative 40 plus or minus the square root of 1664, because we already did that calculation in our calculator, divided by negative 32. And when we did the square root of 1664, so now because we have context, I now would like you to come up with an actual answer. So we want to round our answer to the nearest hundredth. So I'm just going to work with hundredths from the beginning. We have 40.79. So now I have T is equal to negative 40 plus or minus 40.79. This is all over negative 32. So now we have two separate equations that we have to analyze. We have negative 40 plus 40.79 divided by negative 32, or T could equal negative 40 minus 40.79 divided by negative 32. So let's go ahead and put this into our calculator. So I'm going to start off with just putting in my numerator, coming up with an answer, and then dividing it by negative 32. Please be careful. A lot of kids make their biggest mistakes here. We're dividing everything by negative 32. So this is going to be negative 40 plus 40.79. I'm going to come up with an answer. That is my numerator, and I'm going to divide it by negative 32. That's a negative 0.02. Down here, I'm going to put in my numerator. My numerator is negative 40 minus 40.79, and I end up with negative 80.79. I'm going to take that number and divide it, because this really is what my numerator is, and divide it by negative 32, and I end up with 2.52. Now, we're talking about time here. Can time be negative? No. So in this case, that solution of T equals negative 0.02 doesn't make any sense. This is our actual answer. So to answer our question, we're going to say that after 2.52 seconds, the ball will reach a height of 3 feet. Letter C says, how else could we have solved this problem? Well, there are two different ways that you could have solved this problem. Quadratic formula can solve any type of equation, and so can completing the square. Technically, we could have completed the square in order to solve this problem. But looking at how nasty it is, we would have ended up with really awkward and terrible fractions as we were working with this problem, and I strongly would not have recommended working with completing the square. But could you have? Yes. The second way that you could have solved this problem is you could have used your graphing calculator we could have graphed the function. And we would have put in y equals, or y sub 1 equals negative 16t squared plus 40t, which would have been x, plus 1. And then the other function, we would have had y equals 3. And we would have looked, I'm going to say graph the functions. And we would have looked at the points of intersection. Because the points of intersection would have been the indicator of 2.52. That would have indicated where or after how much time the parabola would have had a height, or the ball would have had a height of 3 feet. So what that would look like if we were to graph this is we would have had ourselves a function or a graph that would have looked something like this. If you can imagine the path. And then at y equals 3 would have been something up here. And we would have just been looking at where was the point of intersection. Maybe it probably would have been down here because we have a negative and a positive solution. So we would have probably been looking down here. Anyways, that's what we would have done. Anyways, let's go ahead and end this video lesson. If you have any questions for me over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.